Weather's kind of cool.
Yeah.
All right. Good afternoon, everybody. Welcome to our weekly public health seminar. Today we have another health department presenter. I'm sure you guys are wondering if this is just a health department seminar series, but it's really not. There's going to be all kinds of speakers over the next several weeks. But kicking off today, our environmental health topic, Elena Evans is here to present on harmful algal blooms and the importance of water quality. We're very excited to have her here, but I wanted to take just a moment, invite people next week, October 9th. We will have Cinnamon Salway, director of the Browning Public Schools Good Health Program. So she and several of her staff, I think that's virtual, is that correct?
No, they're coming down.
Oh, they're coming down in person, all right. So Cinnamon and several of her staff will be here in person. So we invite you to join us next Monday for that. And I am pleased and excited to bring up Elena Evans to talk about harmful algal blooms today.
Hi, everyone. I'm excited to be here to talk about harmful algal blooms and water quality. So it's really a great opportunity to draw attention to the importance of water quality through the lens of something that is a little more urgent on the top of a lot of people's minds. So does anybody have dogs? Anyone in here have dogs? Yeah, so do I. This is my dog. She's a little obstinate, but she loves the water, full of fur, needs the water. That's the case for a lot of people around here. Other things that need water are tiny humans and humans in general. So those things together and this Montana landscape, that's kind of a big part of our community and why we're here. And I'm not sure how many of you recall or were engaging in the middle of summer this year. There were a lot of concern on social media regarding dogs going down to the Clark Fork River and thereafter, dying. That was the third-hand account that was repeated on a number of different social media sites. That's quite a concern, and it's something that the Water Quality District wanted to look into. So in addition to trying to track down where those accounts came from, aside from third-hand accounts, we needed a primary source. We also started to take a look at different water bodies. So kind of shuffling through all of the different information with the help of our public information officer, we kind of honed in on a lot of people's concern was Jacobs Island, and that's where the dog park is. So if you take a look at the picture on the left, you see a picture that's pretty descriptive of one of the main areas where dogs are swimming. In this picture, you don't see any algae. The water's moving kind of quickly. And so when these rumors arose and there was concern, we went to Jacobs Island. We kind of walked the island and weren't able to identify any areas that really had a lot of backwater, slow water, areas we could see algae or anything like that. And that's what made it really hard with that third person account, because if they're concerned about an area, we really need to test that specific location. Otherwise, it could be a large number of tests, or we could say no concerns, and it wouldn't necessarily reflect the danger to health or animals. So luckily, after talking to a few newspapers and saying we'd love to talk to the primary source, we did receive a phone call from an individual who said that their folks had taken dogs to Harper's Ferry. And it seemed like it lined up enough with the public accounts, the third-hand accounts on social media, that we followed that to the specific location at Harper's Ferry fishing access site, which is, downstream of Missoula, closer to Frenchtown, and we're able to take a sample there. Because of the concern, we found this on the right, the picture of the algae, and it's a little brown. It does look a little off, but it certainly wasn't telltale of blue-green algae and what we'd anticipate from harmful algal blooms. All the same, we worked with the Montana Department of Environmental Quality, DEQ, to do a test of that water sample. And then we also sent a sample to the EPA, and both samples came back as not having toxins. And so this is all just kind of the impetus for this presentation in many ways, and some of what we want to inform the public about more moving forward. So this is the follow-up headline that I just pulled up today: Clark Fork algae not to blame for dog illness. So we talked with the owners and we talked with their vets, and those dogs had some other health issues that were ongoing, and it was just coincident with the trip down to the river, and that's the case with a lot of health issues in terms of that. But more broadly, harmful algal blooms, what are they? So harmful algal blooms are cyanobacteria or blue-green algae, and it's the overgrowth of this blue-green algae and bacteria that can photosynthesize. So cyanobacteria and blue-green algae are normal in water bodies at very, at lower levels. It's usually when some parameters, water quality parameters or others change, and they overgrow due to excess nutrients, increases in temperature, and things like that. And when they do so, they also then change the dynamics of water around them. So some blue-green algae can produce toxins, anatoxin A and microcystin. Those other blue-green algae don't. Blue-green algae that produce toxins in one environment may not necessarily produce toxins in another environment. So, this picture is pretty evident of what blue-green algae looks like. It's hard to say necessarily whether that would be producing toxins, but that's the first sign that you should take it into account. And if you're out and about in and around this area or elsewhere in the state has a tool where you can report harmful algal blooms at hav.mt.gov, and that's important. You'll want to take a lot of pictures to be sure that they have as much photographic evidence as they can. So this is a picture of that site where you put in your report, and they post it. They're not able to investigate all of them. Right now, as we're anticipating snow in the mountains, we wouldn't anticipate any closures as a function of harmful algal blooms, but in the summer, June, July, and August is when that's more probable. So this year, 77 harmful algal blooms were reported. 52 were confirmed to have cyanobacteria, so not all of them. There was necessarily a microscopic analysis or the ability to identify whether or not they did, but 52 were confirmed to have some. 26 had toxin information, so they were sampled, and 10 of those exceeded the recreation criteria. So that's just kind of going to show how those get whittled down into whether or not the toxins are there. But they are pretty widespread, and in most parts of the state, they are predominantly on reservoirs and lakes, standing in still bodies of water. So they're widespread, and this is kind of what you want to look for. This is the archetypes for what you would expect for blue-green algae on the bottom, and then just green algae on the top. So on the bottom, it's pea soup, paint clippings, and just like a really vibrant change in the algal populations. And blue-green algae are usually floating. So up on the top on the left-hand side, those are more of nuisance green algae. So similar to cyanobacteria, blue-green algae, green algae can also get overgrown and dominate the population. But on this top left-hand corner is Cladophora. And so in the primary tubing routes through Missoula, if it's filamentous, so if it's stuck to the ground or the rocks and it looks like that, that's going to be green algae and isn't something that would produce toxins. Even if you do see this or something that looks like it is cyanobacteria, the next steps that would occur would be to take a look at it under the microscope and use a dichotomous key to kind of key out whether or not it's cyanobacteria or not, whether it's likely or not to be a kind of bacteria that would produce toxins even within blue-green algae. And then another option is to run test strips on it. So COVID test, pregnancy test, just kind of a presence or absence for that bacteria. And then the EPA testing goes to a lab and they do ELISA analysis. And that really is much more precise in terms of the concentration, but it also does take 48 hours to get those results back. And so what's key in that is in this larger picture on the right, you see Cherry Creek Reservoir in Colorado, so not here, but there was a report and concern because there was that algae really close to the shore. And some people would think, oh, well, that's great. You just hop over it and you're good. But part of the problem is that these algae communities boom and just grow, and then they suck out all the oxygen and tank. So then when they die, that leaves all of the toxins there. So that was the clearer part after the algae had 82 micrograms per liter of microcystin. And that's, you know, the level for recreation is 20. So it's still pretty high, even though it doesn't appear to be. So take care and caution around waters where you have previously seen harmful algal blooms and in areas that are proximal, as they may have previously had harmful algal blooms. This is the Department of Environmental Quality and Harmful Algal Bloom Public Health Advisory matrix, the tiers for decision making. So, you know, on the top you have the relative probability of acute health effects, and then the cyanobacterial cell density, whether or not microcystins or antitoxin A are present, additional factors, health risks, and recommended actions. And so some of it is a function of what data you have available in terms of their decision making, because if they just have pictures, then they're not able to necessarily determine whether or not toxins are present. But they use this in order to, you know, close the beach, determine if there needs to be, somebody needs to go out and get a water sample, or, you know, if there have been reports of animal illness or death or reports of human illness, that kind of helps elevate it in a different way. Especially when the ability to identify whether toxins are present and associated with different bacteria is really, really temporal. So it's short in time as to whether you can capture that toxicity. And if they do go through this matrix and determine something, they'll have these postings. So they'll post it for caution or closure. And, you know, FWP is also part of the collaborative group that puts out public health advisories. And so they're pretty involved when it comes to posting anything at fishing access sites. So when we were testing Harper's Ferry fishing access site, we were in close communication with Fish, Wildlife, and Parks. And the Department of Health and Human Services also, DPHHS, works on this as well. And what are those health impacts? So for humans, it's a variety of concerns. They have potential for stomach aches, headaches, vomiting, neurological symptoms, diarrhea, liver damage, skin irritation. With animals, you know, this can present as excessive drooling, vomiting, fatigue, staggered walking, difficulty breathing, convulsions, and liver failure. So, you know, after we had those reports about the Clark Fork River being toxic, people were very concerned. We certainly couldn't evaluate all of the Clark Fork River all the time. We encouraged folks who were concerned and had these symptoms to consult with their physician or their veterinarian. These are also often symptoms of many other diseases and issues as well. And usually when harmful algal blooms are going to be present, there are more people than normal interacting with those waterways. And so there's also some difficulty in terms of increases in reporting of symptoms and increases in just the number of people visiting. So we, as environmental health specialists, water quality specialists, really ask people to take these issues to their medical professionals, and we'll take a look at the water. And because of all of that and the difficulty in testing and the turnaround and just how elusive the sampling can be when it comes to health effects, the bottom line is, when in doubt, stay out. So if it smells bad, if it smells really pungent and different, if it looks really gross, if that's your first reaction upon seeing it, if it's really warm and really stagnant water, or if it looks significantly different, you go one day and the next day you show up and it's a brown mat or a red mat or a green, you know, it doesn't have to just look like spilled paint or pea soup for you to be cautiously useful when it comes to the water, especially when it comes to dogs and small children. So when in doubt, stay out. It won't necessarily be signed, and it's kind of incumbent upon the public. And this whole program is really driven by citizen science. So, and citizens reporting these concerns. And why is it important even more so now? Well, let me show you a hydrograph. I love hydrographs. So on the left-hand side, you have the volume of water. On the bottom, you have time. And on the right, we have temperature. So this line, the solid line, is how much water we have coming off. And that kind of makes sense because as the snow melts and the river rises, we get a peak, and then it slowly moves back down to base flow. But what we're seeing here is the temperature, and it shifts, you know, diurnally day and night. And when we get up here to around 75 degrees is when there's much more likelihood that there will be harmful algal blooms. That's kind of the key temperature in which those seem to really begin to show up more and more. And that's been demonstrated in a lot of the Midwest lakes and recreation areas where there's even more issues with this, just because those waters get more use and are not moving as much as a lot of our.
Quick clarification, that's the water temperature, not the air temperature.
That's the water temperature, correct. Thanks, Damien. Yeah. So the water temperature, I mean, this is kind of when you get those hoot-owl restrictions, and it's like, whoa, the fish are so hot, please don't catch them. It's also like, ooh, the fish are so hot, the algae's so hot, it's loving it. So it's important to think about that, because there's also less decreasing amounts of water. So all of the other things that can contribute and cause changes in conditions that make it more susceptible to harmful algal blooms are also kind of starting to come into play at that point in time as well. Why is this even more important looking forward? Well, these are downscaled global climate model predictions for our state. And we don't really need to look at the differences because they're all red. So it's not really looking like temperatures going down, it's likely going up. And although there isn't a one-to-one increase in temperature and water temperature, it's something that we know is coming. And so what can we do in light of that? Well, we can understand and know what increases in temperature does to water quality and how we can make our waters more resilient, not only to harmful algal blooms, but also climate change. And in order to do that, we have to understand a little bit about how increases in temperature impact other components that are crucial to water quality and keeping our water high caliber. So this just shows temperature in the middle, just touching everything, helping drive everything. And I'll just talk about a couple of these. So pH, this has to do with whether something's acidic or base, and that's crucial with where different things live. I like this one because it very clearly shows you where fish die and where fish live. And really, the key thing here is as temperature increases at a very basic level, then the water becomes more acidic. And so that's going to impact which plants and which fish and kind of those ecosystems as a whole, and where the area, the slice of pH that things thrive and survive in is going to be less broad. And pH in lakes is particularly important because what you have is wind mixing and dissolved oxygen on the top. On the bottom, you have decomposition. And when you don't have as much of a difference in pH or temperature with the thermocline, you can cause really big increases in communities and just kind of cause those lakes to go eutrophic. You see a bunch of algae on the right hand side, and that can kind of cause all of the different parts of the lake to no longer function or change over in the way that they had previously. And so that's where in oligotrophic systems, like really happy lakes, you have dissolved oxygen, and then on the right hand side, once you get an excess of nutrients and pollutants, there are going to be less of an opportunity for the ecosystems that came into being with these conditions for. Another crazy chart, but basically what it shows is as temperature increases on the bottom, the solubility of salts goes up. So the warmer it is, the more salts are going to dissolve in water. And what that means is that as you have more salts, it conducts electricity more. That's like the conductivity electricity, but it also is going to drive how much a cellular organism has inside versus outside. So it's going to change how fish and other organisms are able to retain or keep water. It's like your fingers being in water and they get all pruny. And so it's similar effect to that. But as we increase the temperature, we are able to keep more salts in the water, and that makes them less resilient. We have saltwater, heavier water sinks. Fresh water is able to hold 20% more dissolved oxygen than salt water, and that's really crucial when it comes to our freshwater ecosystems and fish and things like that. Here we are again with a hydrograph. We still have on the left the volume of water, on the bottom we have time, but on the right we have conductivity, and that's that measure of not just salts, but also, small mineral particles and the things that the water's carrying. Kind of like how chewy the water is would be maybe a really basic way to put it. But as water volumes decrease, we have greater percentages of conductivity. So it's carrying more of that. You don't have the power of dilution to protect that water. And dissolved oxygen here we have, it's key. You'll kind of note on this diagram on the far right hand side, dissolved oxygen can change over the course of a day as a function of plant material and how they're metabolizing and photosynthesizing. And then dissolved oxygen above and below the thermocline in lakes can also drive where you have that productive activity in lakes. But dissolved oxygen, again, is impacted by temperature. And so that's why temperature impacts solubility and conductivity and how much dissolved oxygen the water can carry. And then we have some of these pollutant factors when it comes to nitrogen and phosphorus, which are also key when it comes to what harmful algal blooms, and then also how much carrying capacity of water for those different pollutants and contaminants. And that leads us to our oligotrophic and eutrophic lakes again. So how happy are our lakes? How much can they carry? And what does that mean for them when it comes to harmful algal blooms? the eutrophic lake is less resilient to aquatic invasive species and harmful algal blooms than an oligotrophic lake. And on top of that, even more so, as temperature increases, you have the metabolic rate. So how fast the algae grows increases, and it increases at a different rate for different species. And that's how the harmful algal blooms continue to kind of outcompete all the other algae and kind of explode in their population at certain temperatures. It's because they're just able to proliferate at such a greater rate. And so I know that was a lot of key terms, but basically once you increase the temperature, it can kind of have a cascading effect. And all of these pieces of water quality add together to demonstrate and make our water either more resilient or less resilient when we have these perturbations such as harmful algal blooms or aquatic invasive species or other pollutants. And so, you know, we have that, we have growing populations and growing use, but it's not all negative because we can do things. So the key in preserving our waterways and kind of trying to make them more resilient in light of climate change and everything else in terms of human impacts coming their way is to maintain as much of a natural channel, as much a riparian area as possible. Those trees, those willows, what you see in kind of upland areas and wooded areas are important to shading and decreasing temperature impacts, and then also tying into the groundwater table. So if things are too out of whack and in size, then they're not able to be shaded or interact with groundwater to where they can be moderated. Their temperature can be moderated in ways that will help increase resilience. We can do some restoration and revegetation of riparian areas. We can also do low impact design. So make sure that our stormwater, as climate change causes more increases in extreme rain events and things like that, that we take that water and slow it down, decrease the number of pollutants it brings with it, and also decrease the temperature, hopefully, at which it joins our streams and rivers. And you know, these things, as well as just being aware of what's coming our way and how you can be in charge of when you're going into the water and your dog is and your kids are, that can really help. Another thing kind of outside of the temperature issues that are prominent when it comes to water quality is this is going through the old Milltown Dam site. So as we clean up some of these pollutants and Superfund sites, we can also, that'll make our waters more resilient. So, you know, in the 80s, it would have been unimaginable to have people floating through the confluence of the Clark Fork and the Blackfoot, and that the Milltown Dam would be removed, and that's that whole reservoir cleaned up and remediated. And so right now we're working on doing something similar at Smurfit Stone, as that's also something that impacts our waters. So it all comes together, all the different pieces, to make our waterways more resilient to climate change and less susceptible to harmful algal blooms and aquatic invasive species. So that's my presentation. I think that was pretty fast, so I think there's a lot of time for.
Yeah, so on one of the slides you showed what, to me, as a non-environmental scientist, looks like a COVID test.
Yeah.
A rapid test.
Mm-hmm.
Are those available to the public, and would it make sense to have them available to the public or not?
So, I mean, you're a good person to be asking that, Damien, because we bought some And we have some at the department, but they are like, $500 to $800 for a 5-pack, and they expire. And so that's why it's pretty important to do that microscopic analysis first. And then some of it also comes down to, when the algal bloom was seen and if you would be capturing the cyanobacteria, if it's a public recreation site, if it's only accessible by private land or through private ownership. So we're kind of working through those things. The Department of Environmental Quality and the Environmental Protection Agency certainly have a lot of insight into whether or not they want us to test something. But given the turnaround time after this summer's events, we wanted to be a little prepared more so than shipping a sample to DEQ. So I certainly wouldn't say that we'll be out and monitoring waters, but oftentimes if people are concerned, we can take a look. And then also, with that hab.mt.gov, DEQ, if it doesn't come to us first, may also reach out to see if we could go investigate and take a look, to see if we visually identify it or if we're able to identify it under the microscope. I mean,
But it's not something you can't go to Ace Hardware and pick them up for $5. It's
no, they're pretty expensive, and they are definitely also limited, in terms of you have to buy 5 and then they'll expire pretty much within a year. So that's like 1 season. So, but I think, there's like general rules of thumb. Well, you have 2 thumbs, but anyway, if it's like stagnant water and it feels really warm and it, looks gross and smells gross, please just stay away. And certainly if it's a public area, then maybe, we'll work with Fish, Wildlife and Parks or city parks or county parks.
So feel free to say what we say in academia very often, which is that's not my area. If it isn't, but so I'm more curious about maybe something we were talking about before you started your presentation, Elena. So I have a dog, and I, like many people, had people texting me,
Yeah.
like, oh my God, don't allow your dog to go in the Clark's Fork. What are I mean, I know you check things, those things happen all the time in different areas, but in particular this area, what would I do? Would I call your office or act cautiously to begin with? Or?
Yeah, no, I mean, I think when it gets hot out, act cautiously to begin with.
Okay.
Before I take my kids or my dog to a fishing area, I like to check it out before I let them out of the car. Because my dog, well, she doesn't listen to me to begin with, but if you haven't been to the area, it's key to check it out. I think it's also good to think about what's happening with the water. If it's a lake, then it's standing still, and so that's going to be a little riskier than running water. Like we talked about at the beginning, Jacob's Island, water's moving through there. It's not standing still, so the likelihood of having a harmful algal bloom there is fairly low. The backwater areas possibly. So I think once we get up to hoot owl type restrictions and once there are reports of it, then I'd check something out before you let your dog off leash.
Okay.
But yeah, rivers generally safer than lakes. Most of the harmful algal bloom cautions and confirmed areas have been lakes and reservoirs. They haven't been necessarily in rivers, but the areas of concern have been backwater eddies.
Thank you.
Yeah.
If there are any questions online, would encourage you to go ahead and unmute your mic or put a question in chat. We'd love to hear from any of our folks online.
Are people excited about conductivity? Solubility?
Here's a question. We're originally from Pennsylvania, an area that has a lot of agriculture.
Mm-hmm.
There was concerns over the last several couple decades about the amount of fertilizer being used on farms, having a lot of nitrogen getting into the water table, coming down into the main rivers that basically feed out into the bay near Baltimore and out into the Atlantic Ocean. Do you see a lot of that issue here in Montana, the use of fertilizer and how it affects the water situation?
Yeah, I mean, so there are areas where that is a big concern. The Gallatin River was almost listed on the Department of Environmental Quality impaired streams list for algal blooms as the actual listing issue. And I don't think that was necessarily just because of, applying fertilizers and things like that, but it is certainly an impact. What I would be more concerned about is like golf course ponds and things that are closed basins. So the nice part about rivers is there is that big hydrograph, and so oftentimes the dilution power and movement power flushes those downstream, and that's not the case in lakes and reservoirs, and so that's where we see more of the fertilizer issues. And fertilizers, particularly if they're being applied right up to the edge of a lake, that's where those riparian and lakeshore buffer areas are pretty key. And I know different conservation districts and watershed groups and folks are working on trying to pull people back up off of the edges of rivers and lakes and give our waterways a bit more of a buffer. In Missoula County planning and the zoning code update, there are now like riparian buffer requirements. That's pretty innovative and important to keeping our waterways resilient. So I think it's certainly more of an issue in the East Coast and in areas where there isn't a snow melt driven hydrograph in the same way, especially because those waters aren't quite as dynamic. And so you'll get the lingering effects of those fertilizers to stay put a little more. But that's also where in, Minnesota, the Midwest and East have a lot of research on harmful algal blooms and a lot more experience with identifying them and addressing them. And it's unfortunately just something that our community is going to have to get used to thinking about a little bit more, especially in late summer.
Thank you.
I have a question, but it's a two-part question. So the first part's okay if you don't know, but how common are closures in Montana due to this? And when there are closures, is there some kind of treatment, or is it we just close it until it naturally rebalances?
Yeah, so for the first part, there aren't that many closures in Montana. There have been on the reservoirs a good number of times. The conditions are just pretty ripe there for this. And so those closures happen more often. There isn't a way to really treat harmful algal blooms. The only treatment is really like preventative maintenance. And so it's taking care of the water quality elements to reduce the likelihood of the conditions to be primed for harmful algal bloom creation. Particularly on the reservoirs, if you get a good amount of wind or there's more mixing and it gets broken up, then that's something that can help, but doesn't necessarily always help. And so with the closures, those are usually for 2 weeks after confirmation anyway, just because it's hard to be sure, if it's producing toxins now, will it likely be? If you test again and it's not, does that mean it's not? It's kind of hard to say. So in places like Minnesota, like the Minneapolis Parks and Rec or St. Paul Parks and Rec, they test a lot of their swimming areas pretty frequently, just given the frequency that they have and the issues they have with harmful algal blooms. And swimmer's itch and all those other things, so yeah.
All right. Thank you so much.
Thank you.